everybody, and welcome to another Desk of Lady Ada. It's me, Lady Ada, and I'm at my desk. And every night I try to bring to you a little sliver of the engineering life, the e-life, as I call it. And then, if you're watching, I've been working on and off on the circuit playground. I did, some breadboard tests of stuff, and then I did some layout, and then I did the routing. And then I sent off the PCB last week, and I got it this week. It's purple. It's not from Oshpark, although you should totally use Oshpark for your prototypes. But it's a lovely purple prototype PCB. And I thought I'd also try out this new HDMI microscope that we got. We demoed it a little bit before, but I thought this is a perfect opportunity to show stuff surface mount soldering. I thought maybe I would surface mount solder this PCB. It's lovely. It's round PCB. It has 0603 components, QFNs, some 3535 LEDs, JSTs. I just kind of go. I'm probably able to finish the whole thing in 30 minutes because it's quite a lot of parts. But I have a stuff sheet here that I printed out. And a stuff sheet's very handy. It's basically just a printout of the EagleCAD, as large as you can get on one page. And all the components are labeled like the values, just a 10K resistor and it's a 1 microfarad capacitor. And for the chips that are not, just chips, for the resistor capacitors, these are labeled so that we can follow along and start this baby up. So let's do this thing.
Yeah, and before we get started, because sometimes there are journalists who want to get to know you, is this what you do? Is this it?
This is it.
This is all it.
Oh, yeah.
So this is how you work, this is what you do. We're just throwing a camera on it.
Right. I mean, there's also, we had to do the wrap up of the 401k for this year, and we have to...
we run a company.
Run a company, and we have 360, reviews, and we've also got new products that went out, and I just approved a couple new products. I'm also, the reason I'm actually not doing computer stuff tonight is because I'm compiling a new Raspberry Pi kernel, and I kind of want to let my virtual machine do its thing, because it's going to take an hour to compile. But that's exciting, too, and maybe we'll get USB Gadget working on the Pi Zero.
Well, let's get to it.
Anyhow.
Because I can send this video when we say, here's all the stuff that Adafruit does and more does.
Yeah, that's what I'm doing.
Yeah, okay.
This is a real prototype.
Yeah.
Not like those fake prototypes.
All right, do we want to go to the overhead or which one?
You go to the overhead? Or the microscope? That's cool.
Yeah.
I thought, you could switch between, whatever, you could play around with it. So you don't get to see the whole PCB because it's a little bit big. But this is that micro USB jack, goes into an Atmel. There's a crystal over here. Reset button, resistor packs, 2 buttons, switch, a little speaker. If you remember that speaker I tested a while ago, regulator, ground, JST, and Schottky diodes. I thought actually I would start from the bottom, the bottom of the PCB basically, and do this section first. Hold on, I'm going to, this is, sorry, I'm just kind of learning how this microscope works. Okay, that's good. And it's got these nice little grippies here that will hold down the PCB, kind of, sort of, a little bit. The only thing is, can I move this back at all? No, but I can lock this down. Okay. All right, so let's start with the JST. Okay, I got my Hacko. This is a Hacko FX888D. You don't need the D, you can use the analog version.
You can kind of see all the opportunities for future paid product placements.
Using the Hacko.
Yeah.
So at work, actually, I don't use a Hacko. This is actually the demo model that we got when we first got the Hackos, and we wanted to have one that we were demoing with and testing out. This is that model. At work, actually, I use a Metcal. And it's got fast removable tips. It's kind of hardcore. It heats up really fast. That said, you can switch tips on this. So, for example, I can show, this is a large tip. You can see this is a little bit too big for some of the pads I'm talking about here. This is really good for through-hole stuff or big heat sinks and stuff. And then this is a slightly smaller tip. I can compare these 2 tips, actually. And that one's gotten a little bit of wear. This one's kind of shiny. And you can see it's a little bit smaller. These are screwdriver tips because they have, a screwdriver end to them. And then this is the tip I'm going to be using. So it's a needle tip, very conical, fine point. And you can see this is really good for touching up little pads. So I'm going to wet my pad here, a spongy sponge. I'm a sponge person. Some people are the brass mesh people. That's cool, no judging, but I think it's silly. I like the sponge. Okay, so let's place this JST. Actually, you know what? I'm going to rotate. Ooh, that's good. I'll rotate it like that. Okay, so use. I think I'm using leaded solder here. My home isn't lead free. At work, I don't use leaded solder. We use lead free only. But I'm here and I don't have a Metcal of a Hacko, so I'm like, whatever. I need a little bit more help maybe to get the really fine pitch stuff. So might as well use leaded. So get that pad ready. I've got my tweezers. These are actually the first pair of tweezers I ever bought, and they still are great. These are from Germany. These are VOM Germany, ESD, fine point. And, I've dropped a couple times and, bent them back. But they've survived like 15 years. Pretty good. Grab your piece. And then melt the pad as you drop it in place. Okay. Looks pretty good. I'm going to just shove it over a little bit. Okay. Then you can do the other pad. And then this part actually has some supporting mechanical pads. So you can get the sides. To make sure that you guys can see what I'm doing. Okay. Yeah, you can barely see the corner pads, but yeah, there's these little mechanical pads. They're not electrically connected, but they serve to keep this connector nice and solid. So yeah, it's not going anywhere. Okay, since we're over here, let's do the Schottky diodes. So there's two pieces. Right in there. One over here. So my technique is I dot one of the pads, and then this is the Schottky diode. So these are polarized. So I'm going to look carefully which direction. These are the polarity protection for the power supply. They select between the USB and battery. Actually, I'm going to bring this over here. And then get myself some light that way. Okay. That's a lot easier for me. Okay, then we can get the other pad. And then spin it around. Grab another Schottky diode. This one goes this way. Just melt the pad while it's on, sitting in place, and hit it up. Okay, cool. I'm going to skip the resistors and capacitors. There's like a resistor over here, I think, and a capacitor over here. I'm going to skip those and go straight to the regulator because I want to. I'll do all the resistors and capacitors last because those are not that interesting. All right, so this is the SOT 23.5. Not too bad with a fine tip. Just dot one of those pads. This is the chip. It's upside down. This is a 3.3 volt regulator. I don't remember exactly the part number. Could be a AP2112 or LP2985. I don't remember exactly. Okay, so it goes over there. I'm going to rearrange my stuff. This one's a little tougher than the bigger parts, but you hold it in place. Get that one pad soldered down. And then it's not too bad to get the others. A lot of it is about getting mechanical strength to start, and then you can go in and you don't have to be as delicate. Like, I'm actually going to bridge a little bit there. That's cool, no biggie. Grab our handy dandy wick. Okay, it's actually hard to use wick at this angle. Okay, there you go. Clean it up. I think it's probably good. All right, let's do this. Let's do this switch next. A nice big switch. This switch is just a general purpose switch. I'm gonna turn on, turn off, whatever you like. There's two little bumps that help it sit in place. You just have to make sure that when you're doing that first pad, you get it to sit down in place nicely. Hit up the opposite corner, and you can do the rest. Okay, it looks like I have a little bit of a bridge to that pad. And clean it up. Looks fine. Yeah, some of 603 components. Luckily, when you pick in place, this isn't a big deal. Now let's do the buttons next. So let's do this left button. I tend to do the lowest components first, but since I'm videoing, I thought let's do the easy components first. How does that look? That looks pretty good. Maybe bring it up a little bit. Okay. Getting all the little corners. Okay. Looking good. Okay, let's do the right button. Like snake around the microphone or microscope. Okay. All right, not so bad. Got some larger parts on there. And I'm going to skip the reset button because I'm actually going to go dive right into doing the QFN. I tend to do the toughest parts first because if I have to do hot air rework, which I don't really want to go grab the hot air and get anywhere near this kind of expensive HDMI microscope. So instead, I'm just going to try to do the QFN now, and then I'll be able to finish up around doing all the parts around it. Just sort out all these parts I've got. A little baggie of parts. Okay, so QFNs look like this. Very small leadless parts, and when you pick and place them, they're great because they're very small. The leads don't bend. Very annoying. They're actually easier to rework, in my opinion, than QFPs because you don't have to worry about pins bending. Because like if you have a QFP and the pins bend while you're drag soldering or wicking, and then they touch, it's kind of a total pain to fix. And especially if the pins break, it's over. The nice thing about these is there's no pins. Pins are, you know, they wrap around the edge here. You can sort of see the little gold glint of the wraparound. But you don't have to worry about any of the pads breaking off. But they're a little tough to solder. However, you know, it's completely possible to solder them with just solder and a little bit of wick. I've done it. You do have to, I might have to grab it and just kind of eyeball it. Because even though this microscope is very good, it's tough to angle and keep stuff in focus. So what you want to do is actually, if you have paste, you can put paste down. But since I don't have paste with me, you get a couple pads with a bit of solder on them. Now I happen to know that the bottom pad is a thermal pad, not a ground pad, and I'm not even doing that much stuff thermally with this chip. Like it's not passing a lot of current. So the right thing to do is to hot air this, put a little bit of paste on the underside so that you get a thermal connection to the pad. But since it's a prototype, and again, I know I'm not passing that much current through it, like it's going to be sourcing like maybe like 220 milliamps total. It drives like 2 LEDs that are low current. It doesn't power anything. All the GPIOs are like basic GPIOs. So for a prototype, I think it's okay. All right, next up we want to align it correctly. That's the worst if you solder on a chip and then you're like, oh, that turns out not to be the number 1 pin. Okay, that's the number 1 pin. You see it's a dot. It doesn't always, you know, have to do with text alignment, so make sure you look for the dot. Also, another thing about QFPs, they tend to have 2 dots, which I really don't. One's a molding dot and one's the dot, so watch out. And then here is, you can see, hold on. Let's bring this down a little bit. You can see it's a little hidden, but this is my dot marker. So it aligns this way. And the toughest thing of getting this started is you want to make sure that you have the chip aligned on all 4 corners. It's a little bit easier to start with a QFP. QFNs are like a little tougher, but again, you can do it, and you know you have a little bit more. It's a little easier to rework because you can drag and lift, and you don't have to worry about bending pins. All right, I'm gonna get close. No. Okay. Hold on. A little bit of. Got a little paste on the bottom. Solder on the bottom. I'm just gonna clean it off. Okay, I'll take another stab at it. Okay. So the next thing you want to do, and I'm going to have to just adjust the microscope focus because I'm going to tilt it, is you want to tilt it, and then, yeah, I'm going to adjust the focus. I know it's out of focus. You want to tilt it and look to make sure that the little gold, you can see these little glints of gold from the plating. You want to make sure those are lined up. Because this is 0.5 millimeter, like 0.4 millimeter, you definitely have to have them lined up. But 0.5 millimeter pitch, you want to make sure those are lined up as possible. You can see that there's the pad, and then it should go right up into the pin. And next you want to do the same, yeah, I know, I want to focus. It's the same on all the other sides. So a little tougher. Hold on, move my hand out of the way. You can see the pads line up. The gold lines up with the silver pads. Do the same on this side. You can see they line up. If they didn't line up, you'd see it's very easy for them to be slightly skewed. I don't want to skew them so you see what it looks like skewed. Just trust me, you'll see it's bent over a little bit. And then lastly, this side, you can see that they line up. Maybe I can also turn on the light so you can really see it. This is like the secret. You just want to make sure after you get like, put a little bit of solder in. I just kind of like placed it and then just got it in location, tacked it in location. Once it's tacked in place, you just check all the rest of the pads and make sure they're aligned. You'll do another alignment check later. Hey, cat. Cat's excited by this. But you really want to make sure those are all lined up. Okay, so now once that's done, let me get back into this focus and turn this off. You chasing the cat out? What's going on? Cat's gone. Oh, hold on. This thing has a manual focus. Okay. So now that we have done the little bit of tacking on that corner, I'm going to tack it on this corner. Again, if you have paste, paste is the right thing to use here, but I didn't bring paste home. So let me actually align this so it's a little easier for me to get to. And then you just want to melt a little bit of solder, and it's okay if it bridges. You just want to get it in place, and then you can kind of drag solder. See if you can actually see this. There's a little bit of bridging. You can see that, but that's okay. Now that you have it like mechanically like in place, you can go around and really do the rest of it. Hold on, I'm like melting my cable here. That's the biggest problem with soldering on video. Cable melts. Okay, now we can do this side. And when you do this, you don't want to like scrape at the board, but you will feel each of the pads as you solder them. And they should feel, for lack of a better word, individual. You can feel each individual little, because the way it works is that there's the copper and then there's a solder mask on top. And the solder mask makes a valley where the copper is remaining. And so you can feel that with the tip. It goes click, 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 click as you click into each valley and deposit solder. So now let's look at our soldered thing. So you can tell it's not like perfectly aligned, but it's probably good enough. And you don't see any bridging, so that's good. But it's not super perfect. If you really want to go and make this perfect, you can go back and hot air it. But it does, sometimes it gets a little bit out of alignment. Like it was perfect before, but then when you actually solder it, your mechanical movement pushes it around a bit. Yeah, it's hot air is a little bit nicer about this. So let's go through and do the rest of them. So I did this side. Yeah, it's fine. Okay, so let me clean up this side. So this had a little bit of bridging. You don't really need wick for QFN. You just need to do that thing where you drag and then you feel each pad click into place. Okay, and then this is that first side I did. I'll just go through and actually get each pad soldered. And then finish up with this side. And you want to keep your solder tip really clean when you're doing this. Okay. So again, let's take a look. Since this is, so that's nicely aligned. See how that's just like row after row, each dot, that's perfect. So that's what you want to see on that side. And then this side is not perfect. It's a little tilted. See, there's a little bit of a swoop, but it's okay, I think. That one, better than the second, but it's not as good as the first. I do see like a little thing here that bugs me. I want to clean that up. Okay. And then the last one. That one's also really good. So, you know, 2 are really good and then 2 are like iffy. But that's fine. Okay, so that was the hardest chip. You don't need to use flux, man. Flux inside your solder. No, just kidding. If you have flux, use flux. Don't be like me. Okay. Next up, we can do... Here's the thing, actually, for the LIS accelerometer. This little one, you can't do it with solder. You actually have to do it with hot air. And the reason for that is, so it's also QFN. It's got pads on the bottom. But, this is key, it doesn't have the pads extend around. See that? The end, this is actually kind of a reworked piece already. It's completely black on the side, epoxy. There's no pads that go around. So for this, the pads are only on the bottom. You actually can't use the technique I just showed you. You kind of have to use hot air. That's okay. You know, I can always do that later. I can hot air it on. Let's just continue. Let's do the reset button. This is a teeny little button, not to be confused with the big buttons. These little buttons have a little bit of an annoyance in which, if you're not careful, it's easy to bridge to from the pad to the body, because it has this kind of metallic body that it's kind of bends, has this little metal bent part, and it's very easy to bridge. So you just gotta watch out when you do those. Okay, next up, let's do the crystal. Crystals, the way I do them, because the pads are on the bottom, I actually put paste down on all 3 pads. And then I grab the crystal. It's actually a ceramic oscillator, it's not crystal. I have the crystal here. Well, ceramic oscillator, I call it the crystal. Sorry, just deal. And then I want to get this so it's aligned. And then it kind of floats a little bit, but I'm cool with that. And I do that because the oscillators have a metal body. You can see here this is a metal body. And it's really easy to bridge to it if you try to solder from the side. So instead I just do this instead. And then if you're feeling picky, you can push it around. But I think that's pretty good. Take a look. Yeah, it's good. Okay. Next up, I'm actually going to do 2 resistors because I want to do these resistors before I do the USB because it's going to be hard to get to the... Actually, don't do them? No, I'll do the USB first. And it's going to be harder to do the USB than it is to do the resistors, so I'll just do... Because the resistors you can solder from the top. So you get a micro USB jack. These are kind of nice. I like these. These are the standard ones that we've kind of came up with for use. They're good for a couple of reasons. One, they have little positioning dots. You see one little dot there and one little dot there. So it positions on the PCB, and that's good. And then they have 4 through-hole legs. And even though they're through-hole, if you put paste on the pads, they kind of like wick into the pad, so you can surface mount solder them even though they're through-hole. And then there's also a spot, you know, here, which when we pick and place it, there's a little bit of paste that goes down here. I'm not going to put it on here because I'm not going to be wrenching this that hard. Also, I can through-hole solder these. So between this, the 2 dots, and then the 4 legs, these things do not come off the board. I hate delaminated micro USBs because you can never get them back on. And so we kind of went for this like super fancy one, but it doesn't come off. I've had strong people try to wrench it off and they're like, it ain't coming off. So you can begin by, again, because there's those dots, it kind of mechanically sits in place. You can do the 2 mechanical side pads here. And then there's 5 little pads on the inside, which can be a little annoying to get to. And I know it's a little bit lifted, so I'm going to push this down while I solder. Hold on. Yeah, it's not sitting totally flat. Where is that? Okay, well, it's not going to sit totally flat. I can't hold this at an angle while I solder, really, but I can kind of poke at it. Maybe I can. So what I'm going to do is I'll get in there and I'll solder these just by taking a little bit of solder and just pointing it in. So since I can't tilt this, I'm going to tilt myself. And you don't need a lot of solder, you just need like a teeny little bit just to make that contact. Let's look at it. So, yeah, it's pretty good. Maybe get this one a little bit more. The middle one looks a little dark. Yeah, there you go. So you got them all soldered. You can do the other mechanical pads. These are totally not going anywhere. All right. Sweet. All right. Well, let's do can do some LEDs. Let's get a pin 13 LED and on-off LED. And you can see there's a little diode mark showing that this is the anode and this is the cathode. And then likewise, this is the anode and this is the cathode. So, actually I only have a 603 LEDs right now, but that's okay. I'll just solder a 603 LED in here. Let's clamp this in place. Let me see if I have another LED. Okay. And then once you do one pad, you can do the other. LEDs are actually kind of tougher than most. Kind of the weird half oval makes them a little tougher. Okay, let's let's do these two resistors. These are the USB serial inline resistors. The resistor book. I'm going to pull out about 22 ohms, not precision parts. I got 20. Ohms is plenty. I don't even know exactly why these aren't built into the devices. I just noticed that some USB devices you need to add about 27 ohm series resistors, and then some you don't. I don't know if it's the ones that you don't have to, they're built in or not. Okay, so got 20 ohm. Normally I don't work with those 603, but in this case I really wanted to make this design small. Okay. Yeah, see the problem is I just lost my resistor. I can't even find it. Oh, there it is. So let me get this. Okay. And get the other one. Oh, we're at it. These are 1K resistors. Let's do those. $1K-ish. We do have 1K. So, good. Okay. Oh, these are not marked. No, they're marked. They're just very small. I do not like resistors without marking. It drives me a little nutty. And I noticed that Samsung brand resistors stopped marking them. They're all black, and that's the worst. How are you gonna like figure out if you know what values you use? You have to like actually remove the resistor. No good. Okay, got some resistors going. So next step, I mean, we're actually close to the point where we can do a bring up. Let's put on this LED. So these are mini neopixels, which is cute. Cute little neopixels. They come on tape and reel. They're a little bit smaller than normal neopixels. Okay, that's one. And you can tell which way they go because there's a little bit of a notch, see in that top corner? And that notch matches that way. Oops. Got a little. Whoa, that did not even solder. Is that angled correctly? No. Geez. I'm like totally off. Is that angled correctly? Well, corrector. It's probably good enough. The thing is, you want to be very fast because you can tell these like to melt. Being plastic, you can reflow them, but they do not like being hand soldered. It's not saying you can't do it; they just really don't like it. Okay. All right. How much time have we spent on this so far? Timekeeper?
We were at the 41-minute mark.
Oh, we should totally take a break then. We'll get back to this next time, or I'll just finish this up. I think I did the most interesting parts. Yeah, I can try plugging it in, seeing what happens. I don't have capacitors on it. but let's see if maybe the power LED turns on. Ooh, you know what? I heard from my computer that it enumerated. So that means the microcontroller, so you got the on LED is on, and my computer bleeped, which says it found the device. So having found the device means that we got the micro USB good, the 2 resistors good, this chip's good, the crystal's good. If I press the reset button, I can turn on and off. And switch doesn't really do anything. And then I can also try powering it from a battery for fun. Let's see if I have a battery, a LiPo battery. You can plug it in over here. And yep, that works. So it's lit because it's correctly powered. So we got the battery working, the USB working, the microcontroller works, or at least the parts necessary for it to turn on. So that's pretty promising. Crystal, and then what I'll do is I'll put a bootloader on this so I can program it from the Arduino IDE, and then I'll maybe have it blink the LED, and that'll, this NeoPixel LED or this 13 LED, and that'll let me know that the board's up and running. What I usually do is do the minimum necessary to get the basic test going, and then I add more components just so it's like, if I happen to break the board later, it's not like, oh, like what part was broken? I don't know. You just do it piece by piece. So that's that. Hopefully that was fun to watch some HDMI soldering.
Okay.
What do you think? This is probably the only HDMI soldering live stream. Nobody else has like such a nice resolution.
Everyone else is all talk. Sorry.
Look at this, 1080.
Everyone else is all talk. I never see any electronics on the electronic video shows anymore. Just talk, talk, talk. Why aren't they coding? Why aren't they making electronics?
I don't know. All right, so what have we proved? First off, it's a nice camera, and we can live stream it. Second, you can totally do QFNs with just some plain solder. It's thin solder, but it's plain leaded solder, and a Hakka with a fine tip.
You can do it.
I don't know the tip number for this because I don't memorize them, but it's the one we have on the store that's like the micro tip. And yeah, this is a circuit playground. So this will be, next time we do a video, I'll have this all together. Because I don't know how much soldering. I mean, like, I'll solder something next time. And we've done an assembly of stuff, but maybe skip ahead. And then I'll actually, maybe live, I'll go through bringing up each part of the board, like, testing out the LEDs, testing out the sensors, testing out the speaker, testing out the switch, basically writing a test program to try everything out. All these pads can have alligator clips on them for capacitive touch. We'll test that out and calibrate it. The only thing missing now is a cat.
Okay, if you don't pick him up, please.
I'm not going to pick him up.
We'll just bring him into the frame.
What's wrong with him?
He's just energetic. So.
Oh yeah.
Yes, that's a little cat.
Can I sort of like get his attention? Hey. Yeah.
Meerkat. Periscope.
Cat on Meerkat. I can't. Can I pet him?
Yeah, he's just squirmy.
Oh, he's squirmy. No, he's squirmy.
Yeah.
He's a squirmin'. He's a squirmin'.
Yeah. I mean, all I can do is do a drive by here. There's a cat. So embarrassing. He knows he's gonna get on the internet. That's why. All right.
He's a good cat. He will put up with being on the internet.
All right. That's it.
All right. That was some Descaladiata.
See people on Saturday.
We'll do this again soonish.